So hello guys, my name is Olson, and in this video tutorial I'm going to teach you how to make a program in assembly language that will convert a Celsius to Fahrenheit. First I will write all the codes and then I will explain it later on. So here we go. So now that we finished our codes, I will explain each data or code because it is actually more easier to do coding first and then explain it. So now we have here two segments. The first segment is the data segment where our variables are located, and then our code segment, it's actually up to here. So this is our main program, and this piece of codes here is actually the line for our procedure. So um, in a normal or other coding, we only need code segment for our codes if we do not have variables. But if we do have variables that we need to store something or create variables, we need this one. So in solving a Fahrenheit, we actually have the formula that Celsius multiplied by 9 and divided by 5 and overall plus 32. So we actually need a variable that stores the value of our Fahrenheit. And by creating our T variable, dB is a defined uh, code for making a variable, and then question mark since we don't know yet what our Fahrenheit is. And then our rest is and our rest will be the one that we will be outputting on our screen. So rest dB, the size is 10 as we don't know what is the size, so we will just maximize it as 10. Dup means duplicate, to duplicate the value or uh, our whole data that will be our Fahrenheit. And then this piece of code here tells that our line of code will end. So next we need two message variables that will be our portal for our input and then our output message. So our first message, MSG1, which is our variable name for message 1, that will output or has the string enter temperature in Celsius only in 2 digits. So this dollar sign again, it means to it it is the breakpoint or indicates that up this string is only up to this point. And then our message 2, msg2 db 1013. This 1013 means it actually means new line, because if we do not have this, if we do not have 1013 emulate run, so we can see here that the whole thing is only in one line. So in order for it to appear on two lines, we actually have to add this 1013. And then we will end our data segment. So our data segment is named data. And we can actually just put ends to end this data segment. But just to be specific, because there could be a lot of segments, we put the specific data segment name, which is data. And our now we proceed to our code segment. So our code segment name is code. You can actually name it whatever as you want, but for me I will just name it code so that it will go as is as code segment. And then inside of it we will assume this is a predefined thing on it. The data segment, which is the data name of the data segment name of it is data, and our code segment, which is the name is just code. So start is a label where we actually indicate where are going to start. It's just a label that indicates where our program starts. And then this, even though we already have said that our data segment is coming from the data, this part here, we need to store it in our program. We cannot just immediately store our data segment in DS because that is not allowed due to MOV restrictions. So first, we just actually have to put it inside our AX register, and then from our AX register, we move it on our DS. So next is outputting our message. LEA means the load effective address. So our message, which is enter temperature in Celsius, we will move it or copy it to the X register, and this piece of code here is just simply to output it. Or this is the int 21h, it means interrupt. It states or indicates that if all registers are all set, it will do or output. Now this piece of code here is to enter a user data or values. So for us, we actually need 2 digits. So the first, it could be, for example, we will enter 35. The first digit is 35, and that from 35, I mean, the first digit is 3 from 35, so that 3 actually becomes 33 inside the assembly language. So in order to, by default, to put that back to decimal and not as hexadecimal, we will minus 30 because, as I've said, if you enter 3, it will become 33h. So in order to bring it back to 3 as decimal, we will just simply subtract 30 from 33. So from that, okay, so this shows that 33 inside our program is now lessened by 30 so that it will become decimal. And then move AH0. So since our register AX has 2 parts, which is AH and AL, which is the lower byte and this is the top byte. So we actually need to clear the whatever value is inside so that when we multiply it, we won't get the wrong product. And then from that, since 3 is our first digit in the 2 digits, it refers that it is 30. So we actually need to multiply it by 10 so that it will become 30. So mov BL 10, the value 10 is stored in BL, and then BL is then multiplied to whatever stored in our AX. For multiply and division, it is actually uh, default that the value will be stored in AX and multiply. So whatever value stores in AX, for example, for us, we have AL, it will multiply to whatever parameter that we entered, which is for us is BL. So now that we already multiplied it, it is already 30, we then move the 30 back or copy it back to our BL register because we will use it later on to add the second digit. Now we will enter the second digit, and that from second digit, since it's already in ones, we don't need actually to minimize it or maximize it. So as I've said, if we enter 35, the second value is 5, it becomes 35H. Don't confuse this because this is actually our input. So this is our 3 is our first inputted. As I've said, 3 here is our first inputted, and 5 is our second digit that we inputted second. So this 5 actually becomes 35 inside as a hexadecimal and in order for it to become 5 again, we subtract 30h from it. So AL, we move it into AL, and then we clear whatever value stored in AH so that if we multiply the 3 with subtract, it wouldn't actually, it might actually change the answer that we actually need. And then from that, we move the AL to T. And then we now have to do this or this. Yes. So from that, we will put the value 9 inside the DL and multiply 9 to whatever value stores in our AX. So we now have actually 35 inside our AL, so it will then multiply to 9, and then from that we store 5 to BL so that we will divide whatever current value of our AX that is already multiplied to 9. So we actually multiply this like we already have our Celsius that is already multiplied by 9, so that we will actually divide it by whatever stored value in BL. And then once again, we clear whatever values in our AH because we only need our AL, and it might affect as a whole. This actually this actually stores in AX as a whole. And then from our AL, now that it is already this, we just have to add it with 32. So add 32 with whatever stores in AL. And then the load effective address SI is our target register. So res, we will now then uh, have to put something on res. So we actually have hexadecimals, and from that hexadecimals we need to convert it back to decimal so that we can output it right on our screen. So this hex to deck here is my own procedure, so we can actually see it here. So watch I mean what I'm sorry what this does is that first, when creating a procedure, we put our procedure name, the defined code for creating a procedure, which is proc, and then near here is the type of procedure. We actually have two types of procedure, which is near and far. Near is used within the program, and far is when it's not in the program, it's outside of the program. So what this does is just basically converts whatever value that we already have inside AL, or I mean in our AX, from since we already did this and we already store it in our AX by default. Now we need to convert it, because now it is actually in hexadecimal. We need to convert it back to decimal. Since we actually change it like this one, since we actually minus it by 30 earlier, now we have to put it back by adding 30 onto it. And then this actually divides the bx, which is 10, to the our AL, so that each character, or each value I mean, is added with 30h, since we actually removed 30h from each of it. So from that we actually need to add it one by one. So we divide it by 10, and then from that we add 30, and then we moved it back to our SI, which is for us is our res, and that's it. So from that, now that we already have the real value of our res, we just have to output the outcome. So first, our output message 2, which is converted Fahrenheit is, and then we have to output that string from the DX register, and next is outputting the res, or the result of our Fahrenheit, and then after that mov AH 4CH here means we are closing or exiting our program or operating system, and code ends. Code here is our code segment name here, where it started. We can just actually put it ends, just like what I've said with data, but we actually want to end the specific code or segment. Now we will run our code or program. So run. So for example 35, as you can see, the instructions, or they have done their converting the 3 into decimal inside the program, and then 5, and there we have our result. So that's it. Hope you enjoy, and see you in my next tutorial.